Okay, so I'm going to talk about the Atom task. So right now there are, you usually have about 5 tasks on core 0. The scheduler keeps them on the same core, and Atom is the father of all tasks, and these are all his children. Atom is also the father of other tasks. Atom is from Adam and Eve. He's the first task created, and he creates the others. And so on right now we have 2 terminal windows. We have a frame grabber that's making this video. We have the window manager task, that's the wallpaper, and then we have the Atom task. So the wallpaper is the window manager. Atom is this window. You can't type in Atom directly, but you can tell Atom to say hi indirectly. You can send text to his command line. Okay, so Atom can be like a server. He could do it could be a client server. You can also make server tasks really easily. Anyway, as a matter of fact, when you say pop up, pop-up dir view stays put until you hit escape. So here, I'm going to do it. I just made a pop-up that lets me view the directory, and I hit escape and it's gone. So pop-up makes a servant user. There's 1 task per window, 1 window per task, I should say. Only core 0 can have windows. So there's a heap. Each task has a code in a data heap. Each task has up to one window on core 0. All applications basically run on core 0, but then they can make servants on the other cores directly. So during boot, in the kernel directory, it starts in kernel start in real mode, it sets up page tables and patches code, and switches to 32 then 64-bit mode. Then it jumps to kernel end, where it starts initializing stuff. Now it's executing C, not assembly, holy C. And then at the end of this, it loads the compiler during boot, and then it starts compiling. So the Atom task it starts feeding into his command line. It runs the Atom task, and then it goes into a server loop. It's in a server loop when you see it. So Atom 1 is what it does before it enters the server loop. This includes some headers. There's 2 binaries, the compiler and the kernel, and these are headers for those binaries. And then it goes into the Atom 2 directory. So if we do at this point 49,000 lines of code have been compiled. That's during the boot that Atom compiled. Anyway, after it boots, wait a minute. What I meant to say is during boot 49,000 have been compiled. That's not kernel, that's kernel and compiler are compiled ahead of time, and that's 50,000, and then everything in the Atom directory gets compiled at boot, including, okay, so Atom 1 goes in. After Atom 1 comes Atom 2. Atom 1 is just headers. Atom 2 is actual code, and so there's 49,000 lines that have been compiled. It compiles source code just in time. It takes about a half a second to compile 50,000. Then when it finishes, it goes into Atom 3, which is it's in your account directory. Whatever is the account, you set the account when you make the kernel, and the account directory has an Atom 3, and there's a packages in here. So if you want to make a DLL, all you do to make DLL is you just include code. There's no DLL. There's no linker really. Basically, at this point, if you say who, that reports all. This is all the symbols in Adam's table. So when we're compiling, it checks the task symbol table. If it's not found, it checks the parent tasks, and Adam has all these symbols ready to go. So you never need headers. So when we do a directory, it's checking the local symbol table, and then it's finding it, and then it's checking the Adam symbol table, and that's where it's found. So everything is really elegant. So Adam 3, when he gets done, he starts up this Adam 3E sys. It starts up some tasks. Spawn a user, spawn a user. That's why we end up with 2 user windows when we start up. So just to review, when I have a compile that will make all. When you do it, you say make OS install boot. I say my drive. Yours is probably C. Then I say drive D. Yours is C. Then I say the first one. This is for if you have multiple partitions on a single drive. It'll do sequentially. So D, and it's a type 2. It's a hard disk. We probe. Then we can enter. It's 0x1f0, 0x3f4, the master. And so then we want to start up account. I have a subdirectory. You just enter your account directory. Disk cache size, we just use the default, and we use the default options. If you want text mode, or you want a count, and you want no multi-core, or you want to initialize to set to a value memory so that you can catch uninitialized bugs. Anyway, so there. Now the next time I reboot, it'll be the new kernel. You can RAM boot, which does a real fast reboot without a hardware reboot. Anyway, so as you see, I put my startup account in TS. So it's in my home directory is TS-tad, and if it doesn't find a file in a directory, it checks the parents. So when Adam 2 says compile Adam 3, it checks the parents of my account directory and finds Adam 3 here. Then it kicks it back down into the subdirectory with this home. The home is that's how you say your home directory, TS-tad. So it does TS-tad localizations and all those. That when it searches, if it doesn't find it, it searches the parent. So I do have one file that this overrides the others. So localizations, I set my time zone. And then my account's TS is where I put my company. So if you were an employee of my company, we would all use the same company defaults. And then on the distribution, on the standard production distribution, there's files for the defaults. When you have a menu, you make your own personal menu. This is kind of like your desktop, I guess. It's a combination of history, kind of stored history, macros, and then icons, icons are just command line text that gets sent to the command line, or it spawns a new task. Anyway, so how about that?